Okay, probabilities of compound events. These are typically a little bit of work. They're not that difficult, but just getting your stuff kind of organized is the hard part here. So if you roll 2 pairs, 6-sided dice, what is the probability this is 5 or more? So the reality here is if you roll 6-sided dice twice, we can make a probability tree to represent all of the outcomes. So that's the first die. It could be anything 1, 2, 3, 4, 5, or 6. And then under any of those, there's another 6 branches of the tree in all of these spots. So you end up with 36 combinations. 6 there, 6 there. And we could start to make this list of, okay, what's the probability the sum is 2? Well, if the sum is going to be 2, I've got to get a 1 and then a 1. There's one way that can happen out of 36 possible things that could happen. What about a 3? I could get a 1 and a 2. Or I could get a 2 and then a 1. So I'm not drawing out all these, but imagine there's 6 different things below all of them. So there's 2 different ways to get a 3. So this becomes 2 out of 36. If I want a total of 4, I could get a 1 and then a 3, a 2 and then a 2, or a 3 and then a 1. So this becomes 3 out of 36. This one is 4 out of 36. And the question asks, what's the probability the sum is 5 or lower? So I can stop. I've got 1, 2, 3, 4. So if I add all these up, 1 plus 2 plus 3 plus 4, there's 10 ways that can happen out of 36 total ways. So there's your answer, but they're probably going to want me to reduce it to 5 over 18. And just to show you the way this goes, this would be 5 over 36. And then 7 is the most likely combination because it's the only one that no matter what you get on the first dice, it's still alive. Like if I roll a 6 on the first die, my sum can't be 6 anymore. No matter what I roll on the first die, if I'm trying to get to 7, I can still get there. Then they start to come back down. So 8 is 5 out of 36, so like 1 less combination. 9 is 4 out of 36, 1 less combination. So I'm just going to show you how that helps you solve those. I want to do more of that, please. Try again. Clothing store that dyes your hair clothes while you wait. Pick from 4 pieces of clothing, shirt, pants, sock, or hat in 3 colors. What's the probability of ending up with an orange hat? Okay, so this is, I would go, there's one thing that happens, another thing that's going to happen. They're independent, they're not related, so I'm just going to multiply them. What's the probability that I pick orange? Is 1 out of 3. What's the probability I pick a hat? Is 1 out of 4. So this is going to be 1 out of 20. 3 fair coins. What's the probability you get tail, and then head, and then tail? Well, the reality is all the combinations are equally likely. Let's kind of draw it out and show them. So the first H or T is the first flip. This level right here represents the second flip. And then down here is the third flip. And those are all equally likely because it's all fair coins. So really this HHH, there's a 1 out of 8 possibility that happens. HHT, 1 out of 8. HTH, 1 out of 8. HTT, 1 out of 8. So it doesn't matter what they ask you, it's going to be 1 out of 8. Now, it's different if they say, like, what's the probability I get 2 tails? Because there's multiple tree branches that will lead you there. But if they just say, what's the probability you get this, 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 like, all of those are equally likely, so you can just multiply them together. This is really just 1/2 times 1/2 times 1/2. Or 1/2 to the third. Okay, so no matter what he chose in the morning, I don't care what he chose. It's not saying what's the probability of bus, for example, or cab. It's just saying what's the probability they're both the same. So it doesn't matter what I chose on the way there. There's a 1 out of 3 chance that I pick the same thing on the way back. Like once I'm there, there's only 3 options. On the way back, 1 of 3 of them are the same. 2 6 divided by is probably the same. So you would go, I don't want to draw out 36 different branches. But here they are. So here's the 36 combinations of dice. 6 of them are doubles. So that'd be your answer.